All right, 8.5, rationalizing the denominator. Get a couple examples. Let's do square root of 3 over 8. All right, so this one, I have to kind of be able to look ahead. I know the square root of 3, I need to break it apart. Let's use the quotient rule for radicals. I know that's the same thing as the square root of 3 over the square root of 8. I have two issues. The first one is one we've already talked about. I can't leave the square root of 8 as the square root of 8. I've got to reduce that. Also, rationalizing the denominator, what that means, I'm not allowed to have a fraction that has a radical in the bottom. This, I have to recognize, even though it doesn't technically have a radical in the bottom, it does because it's the same thing as this. All right, so I cannot leave one as a radical with a fraction under it. I've always got, even if it won't reduce, I've got to break them apart and then rationalize the denominator. All right, we'll do several of them so we get the hang of it and see it. First thing I'm going to do is, this is the same thing as the square root of 3 over 8 is the same thing as 4 times 2. Hopefully, you're getting the hang of seeing how these reduce and it's not as hard as it was when we first started looking at it. If it is, you've got to do hundreds of them if you have to. This has got to get to where you can do it really easy. It's going to be all the time from now on, you're going to have to deal with them. Just like as often as I can't leave one as 2/4, you'll have to deal with this going forward. It's not going away. So that 4 comes out as a 2. That gives me the square root of 3 over 2 square roots of 2. This 2 multiplies times the 1 out front to give me this 2. That 2 is still stuck under the radical as my radicand, so I've got square root of 3 over 2 square roots of 2. Here's where rationalizing the denominator comes in. I can't have that in the bottom. So the trick, the way I get rid of a radical on the bottom is I multiply the bottom by the exact same radical. Whatever I do to the bottom, I've got to do to the top. The square root of 3 times the square root of 2 is the square root of 6. I can't reduce that. That's as far as I'm going to be able to take that. This becomes 2 times, the square root of 2 times the square root of 2 is just 2. When you multiply a radical times itself, the radicals will cancel out, leaving you with a radicand. So I've got the square root of 6 over 2 times 2 is 4. All right, and we'll look at some more. Let's say, let's look at, let's just do one straightforward. 1 over the square root of 2. Clearly can't reduce the square root of 2, but I can't leave it in the bottom. So I have to multiply the bottom by the square root of 2, and the top by the square root of 2, and I'm going to get the square root of 2 over the square root of 2 times the square root of 2. The radicals just cancel each other, and I'm left with 2. All right, that's essentially what I'm doing every time. Sometimes there'll be a number up front that I've got to deal with. Not a big deal once you've done a few of them. But I've got to, that's called rationalizing the denominator, which means I'm getting rid of the radical. All right, so about the time they don't seem too bad, they always throw a curve at us. What if we have something like, let's look at a normal one first. We got the cube root of 5 over 8. All right, first time we're seeing one with a cube. We're going to break them apart using the quotient rule. That's going to give me the cube root of 5 over the cube root of 8. The nice part is the cube root of 8, that's a perfect cube. So I'm going to have the cube root of 5 over the cube root of 8 is just 2 because 2 times 2 times 2 equals 8. Alright, so I'm good there. I don't have a radical in the bottom. Let's look at one. The cube root of 8/5 is equal to the cube root of 8 over the cube root of 5. Alright, so the top, we already know, we just saw that, it's 2. The bottom, I've got to multiply it by something that will make this underneath a perfect cube. If I've memorized those perfect cubes, I know that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So I need to make this into 125 underneath the cubed root. So I know I need this to be, I'm taking 5 and I'm multiplying it times itself 3 times. I already have one of them. So I've got to multiply that times the cubed root of 25. Whenever I multiply the bottom by, I've got to multiply the top by. So on top, I'm going to give myself a little room here. Got to have myself there. I know that the cube root of 8 is 2. I don't want to multiply the 8 times the 25 and get a bigger number that I have to deal with. Let's just go ahead and say the cube root of 8 is 2 times the cube root of 25 over, this becomes the cube root of 5 times 25 is 125. That becomes 2 cube roots of 25 over the cube root of 125 is just 5. Now, if this 2 on the outside and that 5, if I can reduce those, I have to. But that 5, I can't reduce it with what's under the radical. That's stuck under there, they have nothing in common. Just the numbers out front. All right. The 5th root of 1 over 4x. First step, break them apart using the quotient rule. That's the 5th root of 1. 1 times 1 times 1 times 5 times, this is going to be 1. That's the last part about anytime we do it, a root of 1. Alright, so what have I got to multiply this by to get it to cancel out? I've got to multiply 4x by whatever 4 to the 5th is. Alright, so 4 times 4 is 16, times 4 is 64. It's going to be a big one, right? You can use your calculator. I'm just going to look and see that it... Let's see here. That would have worked. I like that. Let's do that. Let's look at 4. Instead of doing 4 to the 5th, 4 is the same thing as 2 squared. Alright? And that makes it where my number's not going to be near as big. If I can change this to 2 squared, that means I need to multiply this by the 5th root of 2. I need that to be a 5 so that it would cancel out. So I'm going to make this a 3 because 2 plus 3 equals that. I need this one to have a 5 and it has an understood 1 right now, so I'm going to do x to the 4th. Alright, so I'm multiplying by the 5th root of 2 to the 3rd, x to the 4th. Do the same thing on top. 2 to the 3rd, x to the 4th. On top, I know the 5th root of 1 is just 1. So it'll be 1 times the 5th root of 2 cubed is 8. 2 times 2 times 2 is 8. X to the 4th over, this is going to be the 5th root. I'm going to write it just like I have it here so we can see what's going to happen. 2 squared times 2 to the 3rd is 2 to the 5th. X times x to the 4th is x to the 5th. As soon as these exponents are the same, then all of that cancels out, leaving me with the 5th root of 8x to the 4th over 2x. Again, I cannot reduce this 8 and this 2 because that 8 is stuck under the radical. All right, so now rationalize that denominator. There was a little trick. At first I was trying to do 4 to the 5th, which would have given me a huge number, completely overlooking that 4 is the same thing as 2 squared, and that makes it to where I can work with a lot smaller numbers. All right, that's it for 8.5.